there's an inline pressure transducer set up for each of the workstations, okay? And basically what this is connected to the DAQ, the data acquisition terminal block, that little blue thing sitting on the countertops there. You see a little square? That's the DAQ, okay? That basically takes the signal from your pressure transducer and converts it, 12 volt DC from the power supply, feeds that, and that feeds into your laptop, your Signal Express software, okay? It's already been loaded, so it's all good to go. So once this signal gets into Signal Express, it doesn't know what it is. It's an electrical signal, because basically this pressure transducer is it's a diaphragm that contracts and expands based on the water pressure that you're applying to it. So there's like a little plastic, basically a diaphragm in there, that when it expands, it sends a higher voltage signal to the DAQ. When it contracts, it sends a lower voltage signal. So this voltage signal is voltage all the way until it gets to here, and then somehow you got to tell it, okay, what does 4 volts mean? Or what does 2 volts mean? Whatever it may be. Does it mean 100 psi, 200 psi? That's your scaling factor. Okay, we'll walk through that in a little bit here. But it's based on the overall range of your pressure transducer and the overall output voltage range of your pressure transducer. Okay, so the signal is sent here. So the other thing you want to, this is the scaling factor here. We'll talk through this a little bit, but this is kind of some basic algebra. You remember your equations of a line? Y equals mx plus b. So x is your voltage. That's the 1 to 5 volt output of your pressure transducer. Y is the pressure you're trying to convert to. Okay, so if you want to convert a 1 to 5 output, say to 1 to 0 to 1,000 psi. This example here is 0 to 1,000. Okay, so this is what table?
Table 1.
Table 1. Lucky you guys. All right. This is kind of your scaling factor right here. All right. So what do? Well, you solve. You have your 0 here. If you remember in basic algebra, where you subtracted one equation from the other to figure out the variables. You set this equal to the 0 psi. Set this equation equal to 1,000 psi. This voltage is 1. This voltage is 5. You subtract the two equations, you can solve for m. Okay? So this is your m, your coefficient of your slope. And then with knowing m, you can solve for b, the intercept. Okay, so these are the two numbers you need when you set up your linear equation in that program, which I'll show you here in a little bit. Okay, so if this was a different pressure range, you'd have 0 to, say, 100. You do the same process, but you'd have different numbers. The voltage will be the same, but they're all 1 to 5 output volts, okay? So this 1 and 5 will be the same. But this will change, which means your M and your B will change, your scaling factor, okay? So you have to make sure you get that right, otherwise it's not going to read properly in your software. So, and write this up in your lab report. It's one of the things I want to see that you're able to do is, how did you figure out what your scaling factor was, okay? So this is the linear equation from the 0 to 1,000. It'll be a different equation depending on your pressure transducer. The other thing I want you to write up in your lab report is the error. And all the different pressure transducers have different error ratings. I think, but you have to verify this, on the pressure transducer itself, it'll tell you what the error is. And most of them, I think, in here that we're using today is plus or minus 1%. Okay? So if we have a plus or minus 1% using the same pressure transducer of 1,000 psi, if you multiply that out, you have a 10 psi error factor. Does that make sense? 1% of 1,000, 10. If you had 100 here, what's 1% of 100? It'd be 1, all right? So basically, when you were reading something using this range pressure transducer, your reading is going to be a plus or minus this error. So in this case, it's plus or minus 10 psi. In the case of a 0 to 100 pressure transducer, it would be plus or minus 1 psi, and so forth. So in addition to your scaling factor, tell me, what your error is for the reading based on the range of your pressure transducer. Does that make sense? So two things, scaling factor and error. Okay. Any questions on the overall process? It's real simple. It sounds a little complicated, but it's not. It's very simple. Okay? So, what you're going to do is the Signal Express software should get a shortcut. It's under National Instruments, Signal Express. Why not? Okay, you'll see this when you open up the software. Make sure it's version 2015, which they should all be set up. These laptops are really slow, all right, so